Welcome to the last official meeting of 2021. You guys did some incredible work this year. If I had an audio visual, if we had an AV crew, we could have made a montage sort of movie of all the things we've done this year. But just off the top of my head, I know some of us went to the Edison Awards in Fort Myers in April. I know that we were at GLEX. We had 7 papers in St. Petersburg, Russia at GLEX. We had some papers in Australia at COSPAR. We had 6 papers for Dubai, which is where our VIP speaker, where we met her. Let's see. Oh, we had 9 papers accepted in Hawaii, and we're going to be presenting 5 of them soon. And then we've got a whole season of good stuff happening. So, oh, and you guys raised over $200,000 for a CubeSat. Not a bad year, right? And we got 300-page proposals turned into NASA on time. All right, quick show of hands. Who thinks they won their category at the science fair yesterday? Who thinks they won? Colin, you were going against Econch, so who knows, right? Econch had a good board also. Gabe, do you think you won? I don't know, Gabe. Did you say anything or did you just shrug at me? Oh, Gordon Brown says he won. He was in, what was it, Animal Science, Gordon?
Yeah.
Very cool. Very cool. So glad to see all of you. Just a couple of heads up, couple of administrative things, and I'm going to turn it over to our VIP. Next Saturday, if you have not signed up, I rented the movie theater for Spider-Man at 10 o'clock. So we'll watch Spider-Man together. I am not buying you beverages or snacks, but we got the whole theater to ourselves. A couple of you can even take your shoes off if you want, but just sit in the front or something. So I know we have poster work to do, and I have about 5 templates for those of you working on the poster, and I will let you pick from the template. And when it prints out, it's 4 feet by 3 feet. So it'll be just the right size. I made a lot of these when I worked in DC. So, all right, Mike McCarty, you don't think you won yesterday?
One science fair?
Yes.
I didn't hear you say that. I got
Oh,
to my computer.
I saw your board, but I did not see you during the day. I saw several of you, like Dylan and whatnot. So I'm really proud of you guys, and Elliot and Tyler and Owen. Elliot, Tyler, Owen were there. I saw a lot of you. So, Mike, do you need to make any announcement about the space settlement team and how any progress report or anything you need to share out? Now is the time.
Not really. For the most part, we've been communicating through email. So,
Are you getting good participation from your team leaders?
Some of them.
Oh,
yeah.
Okay. Feel free to private chat me, anybody, and also copy me on emails. I like it when you guys, you're taking care of your team business, but you keep me looped in. That way I only have to get involved if you're unable to manage it. I'm gonna give a shout out to ADP, Ava Delaney. I guess she's here somewhere. There you are. Ava's been busting her tail, getting ready for Hawaii. Finley, great job on your paper. We're good to go. Did you get the transcription checked out, Finn?
Yeah, I watched for SciTech. Yeah, I watched it. I just corrected some things and then I saved it and uploaded. And then I'll just prep for like the questions as it gets closer.
Good. So Finley's paper is done for SciTech. I think there's just 2 of us on that. And then Ankith and Dan Portaslevi. Are you here, Daniel? Daniel.
I don't think he's here.
Okay. Daniel and Ankith wrote a paper. We got it uploaded about a day before it was due. And I know they've recorded their video. And I think they're at a place where they have to do the transcription and check make sure the transcription is accurate. So that's great. We got 2 papers in AIAA SciTech in San Diego. We got 5 papers we'll present in Hawaii. Listen, I emailed our teacher contact in the Big Island is going to get us a tour of the Keck telescope. And that's a big deal because that's a massive telescope. So you want to make sure you don't let your parents book all kinds of excursions for you until we get our telescope appointment set. Because I gave our friend, Mr. Herman in Hawaii, I gave him the blocks of time in the afternoons or mornings where we were not presenting so that we can do at least one field trip together. And then I figured some of your parents will want to take you to the volcano that's active on the island. And so it should be a hilariously good time. All right, I see Sebi, I see Sophia, and I see Harriet. Thank you guys for being here. Okay.
I just told Daniel to join.
Okay.
He's here.
Is there any business we need to take care of other than the poster for Hawaii? Because I think the papers, I will look at the papers this weekend. And I know some of you have a debate tournament. I think I'm a judge, so I might see you at the debate tournament. Or maybe is it a high school tournament? I forget, but if you're doing debate this weekend, I might be a judge. So, okay. Any other business? Any other business? Colin, Finn.
Miss Christensen asked me to write a paper for Hawaii, but I only have an abstract, so I don't know what to write.
Oh, hey kiddo, I'm sorry. That was a long time ago. This cycle, that conference is done. But I was talking to Dan Portis Levy about Miss C and I did a podcast with a lady who used to train astronauts. She's a Russian, and she helps to train the American astronauts when they're working with building the space station. Well, anyway, she is a big astrobiologist, and there's an astrobiology conference in Atlanta, and we've been invited to submit. They want us to submit a paper or two there. I don't want to go crazy and submit a lot of papers, but if a couple of you, I know Dan Portis Levy has already expressed an interest, and I know Arnav has already volunteered. If you want to write, we really, like I said last week, we got to come up with some new topics, some new material, and for these new CubeSats. All right. Any other business? All right. Please sign up on the Google form for the movie so I can go ahead and make sure I pay the right amount, to the theater manager. And oh, by the way, I was at a school. I was visiting a couple of schools, doing some interviews. And there was this little kid that came running up to me, like all excited to see me. And it was Mackay. And it turns out, I think Daniel has, and Mackay, right? I haven't seen Mackay in years. I never taught him as a kid. And he's at another
Yeah, I've
school. And he
seen
goes,
Mackay.
what's that?
Oh yeah, I'm still in contact with Mackay a lot.
Yeah, well, Mackay comes up to me and goes, I'm going to your movie. I'm going to be there to watch Spider-Man. So congrats on Dan going out and recruiting new Wolfpack kids, because if you have a kid that's interested in the Wolfpack, you're welcome to sign up that you're going to bring someone. And I certainly don't mind covering that ticket. I just want to make sure I have a good record. So great job, Daniel, on the recruiting. All right. I think I've covered everything. All right. Okay. If you have questions when we're done, I'll be glad to take them. So I know I'm going to talk with Charlie, and if Celine or any of the Hawaii kids want to hang around. Rachel told me she had a swim meet tonight or swim practice, so she couldn't be here. Okay. I want to introduce to you our VIP tonight. Those of you that were in Dubai, the Makadis, Ava, you may remember hearing Miss Irina Stroica present. She is and I'm going to go from memory here. Miss Stroica is a mechanical engineering student at Concordia University in Montreal, Quebec, Canada. And no, that is not where they filmed Psych or Monk. That was filmed in, I think, British Columbia on the west coast of Canada. She gave an incredible presentation about CubeSats and thermal management. And I asked her to do two things tonight. I asked her to share a little bit about her craft and her education. And more importantly, she's welcome. She's also president of Women in Aerospace, I believe, her chapter at Concordia. So she is just a few years ahead of where you guys are and probably going in a direction that you want to. So I'm really glad that she agreed to meet with us tonight. And so it's my pleasure to introduce Ms. Stroica. And if you would, during her presentation, if you have questions, if you'd raise your hand, let me call on you. And if not, you can always put them in the chat box, and then we'll try to do a 15 minutes or so presentation, and then you guys can ask her lots of questions. Okay. All right, Ms. Stroica, the floor is yours.
So hi, Wolfpack team. I'm so happy to be here. So I'll do a presentation a little bit about myself, my CubeSat team that I'm working on, and then a little bit about my work. So yeah, if you have any questions, you can ask me anytime. I also left like a question period at the end. So honestly, any sort of question on me, on my work, I welcome anything. So I'm gonna be sharing my screen. Okay, perfect. So can you see well? All right. So yeah, my name is Irina Stroica. I live in Montreal, Canada, where it gets super cold. We just had a huge snowstorm yesterday, so don't be too jealous. I am 23 years old, so I'm in my last year of mechanical engineering at Concordia University. So I also kind of specialize my classes in aerospace and space. So I've also taken some classes in space, but overall my degree is mechanical engineering. So I've been passionate about space since I was about 12 years old. I think the turning point for me was honestly watching the TV show called Cosmos. I don't know if any of you have seen it, but it's such an amazing show. So it's narrated by Neil deGrasse Tyson, which I love that man. He's amazing, and he really inspired me. But it's based on another TV show by Carl Sagan. So ever since I saw that TV show, I was like, wow, I want to work in space. I want to help humans, explore the vast universe. So that's really what got me into this field. And then I love anything from astrophysics, from astronomy to space exploration. Obviously, I love satellites, been working on them for quite a few years, and then rockets. So you can ask me any questions. I love to chat on any of these subjects. And I also presented at IAC, so the International Astronautical Congress 2021 in Dubai. So that was basically a month and a half ago. So yeah, I submitted a paper on thermal analysis and design guidelines. And yeah, I did a 10-minute presentation. It was amazing, the time of my life. Also, yeah, like I mentioned, I've been working in a student CubeSat team for 4 years now. So ever since the start of university, I joined a group called Space Concordia. We build satellites, rockets, lunar rovers. But I've just always been drawn towards CubeSats and satellites. And so I've had many roles throughout the years. I started as a mechanical member, just working on the overall design and the structure of the CubeSat. And then I was really drawn to thermal. Obviously, it's a really challenging field. How do you make sure that your CubeSat survives all the harsh temperatures of space? And so I took on the role of a thermal lead. And now I'm a project manager for the CubeSat mission. And yeah, I also worked at the Canadian Space Agency. It was actually my dream for a very, very long time. I have this pretty funny story where when I was 14 years old, I was on my laptop and I went on the Canadian Space Agency website and I was like, I sent them an email, a very unprofessional email. I didn't know how to write emails back then. And I was like, hello, I love space. I'm a student. How can I work for you? Please answer me. Thank you. And then I ended up losing the password to that email. So I don't know if they ever got back to me, but it doesn't matter because I ended up working for them a little bit of 10 years later. And so I worked for them for a year and a half. I did thermal analysis for satellites. And then I also worked on high altitude balloons that you can see in the picture over there. So there are these massive balloons that just go really, really high up, kind of at the Kármán line of space. And you can put experiments on them. There's like cameras, there's all sorts of things that they put on them. And so I was working on them for quite a while. And then at the top picture over there, you can see me back when I was in the mechanical team for my CubeSat. And then, yes, I'm also the president of the Society of Women in Space Exploration. We call it SWISE for short. So this is just the Concordia chapter. There's actually SWISE groups kind of all over the world. There's some in Costa Rica, Australia. There's a lot of them in the US. But I started the one at Concordia. It's the first one in Canada. So basically, we're a group of girls that just have a huge passion for space and aerospace. And our goal is to encourage more women and diversity in space exploration. Obviously, as you all know, aerospace and space is just mainly, it's very male dominated. And so we're trying to encourage more women and other minority groups to join the field. So we do really fun events like movie nights. We also film podcasts. And then we do cool panels where we chat with women that are working in the space field. So over there, you can see a picture of us, obviously pre-COVID, of some of the girls, but now we are over 15 women in the group. Yeah, so a little bit about my CubeSat mission. It's called SC Odin. So it stands for Space Concordia's Orbiting Dust Imaging Nanosatellite. I think Odin is also like a Greek god or something like that, Greek god of air. I'm not too sure. But yeah, it would be basically Concordia University's first CubeSat mission. It's part of the Canadian CubeSat project. So it's a fund that we got from the Canadian Space Agency. That was like about 4 or 5 years ago. They were offering 12 grants throughout Canada, and we got the one for Quebec province. So we're really happy about that. So we're a team of about 60 plus students. I think now we might be nearing 80 students. So there's a lot of us. We have all sorts of different subsystems, mechanical, thermal, attitude and control. So we have people from kind of all sorts of fields, but we're all university students working on this. So the launch date was actually planned for this year, 2021. But because of COVID, we didn't really have access to our labs for assembling and testing. So the launch date got pushed to winter 2022, which is next year. So that's really exciting. We're planning to launch on a Falcon 9 rocket from Cape Canaveral, Florida. And then so we're launching from Florida, we're going all the way to the ISS. And then from the ISS, they're taking our CubeSat and just like shooting it in the orbit. So we'll be operating hopefully for 2 years in a LEO orbit. And then, yeah, our mission is to study dust aerosols. So I'll be talking a bit more about that. But first, here's the meet the team. Again, this was before COVID, but we're quite a lot of people and a good amount of girls as well, which is really good. And it's really fun working in a team. Teamwork is amazing. But yeah, so a little bit about the goal of our CubeSat. So we have a camera called GomSpace NanoCam. And basically what we're trying to do is tackle climate change. So from orbit for 2 years, we're planning to image 2 specific regions on Earth. So one of them is in Argentina. There's a lake called Kolwehati. And then the second region is the Namibian coast in Africa. So these 2 regions are actually prone to having a lot of dust plumes and basically a lot of dust from the desert. And this dust only gets worse as climate change gets worse. So we're planning to get some data on that and then send it to some scientists at the University of Montreal. Hopefully, they're able to make a case for climate change and then escalate it to the government. So that's basically our mission. And then here's the design, the beautiful design of our CubeSat. It's a 3U CubeSat, so it has 3 units. It's a 30 centimeter by 30 centimeters by 10 centimeters. And so at the top here, you can see we have a little antenna where we get data, downlink and uplink data. And then we have a lot of solar cells to get power. And this is kind of the aperture as to where the camera will be pointing. So this is the exterior of the CubeSat, what it's supposed to look like, and this is the interior. So just going a bit into the different units, we have the ECU. So that stands for the electronic control unit. This is where we have basically all the electronics. It's kind of the brain of the CubeSat. And then we have a little cube here, the ADCS, which stands for the Attitude Determination Control System. So this cube here helps us to position ourselves properly towards the Earth. So again, as I showed you, we have 2 specific regions on Earth that we want to image. So this cube helps us to position ourselves with respect to the stars, with respect to the sun. We have all sorts of systems in here. And then finally, this is our payload cube. So this is the little camera that I showed you. Our goal is to have this pointing at all times towards the Earth, and then making sure that this camera actually survives, because obviously cameras are super, super sensitive to changes in temperature.
Ms. Stroica, a couple of questions.
Yes.
I don't know, do you just know offhand, what is the latitude of your targets? Because I think you're going to be like 51 point something degrees inclination, right?
Yes. Yeah. With the ISS orbit.
Do you know
Yeah.
what latitude your targets are? Because they look pretty low on the globe to me. Maybe it's just the way the globe is tilted.
Yeah.
And that leads me to my second question. How many passes a day do you think you'll get with your camera over one of your targets or both?
So I think I would have to like probably ask my ADCS team, but the goal is to have 2 passes per day and downlink 2 times for each region. That might be a bit optimistic, but I think that's the goal for now. Yeah.
Cool. And one last question. Here in the US, we have something called ITAR restrictions. Does Canada have the equivalent where I noticed your camera's from Europe, right? I think Space is a European company. So do you have special ways? We had a document that, like only American citizen kids that were Americans could look at it. And do you have something similar where your equivalent of a State Department says you can't share your technology with other nations?
Oh, yeah, that's a really good point. So it's a little bit complicated because basically we are getting a grant from the CSA, so we are subjected to the laws in Canada. For us, we are talking with, it's called NAV Canada, so Navigation Canada, and then we have also kind of Transport Canada. But because we are launching from the US and then we have a contract with Nanorox, I know there were some ITAR issues, but I think we filled out all the paperwork and everything is fine. Also, between Canada and Europe, kind of with the Canadian Space Agency and the European Space Agency, it's not that difficult. But I know in the US, it's much more strict.
Right.
Yeah.
Right. Very good. Thank you. Remember, guys, if you have questions, I can't see your hands, but if you'll put them in the chat box, I'll pause Ms. Stroica periodically and let you ask your question.
Perfect. Yeah, and also to answer your other question, it was so in our team we also have international students. We have some students from the US, some students from Africa, I think Australia, and they haven't had any problem working with our CubeSat or the information, like sensitive information. So yeah.
Cool.
All right. And again, yeah, you can stop me anytime for questions. And here are some pictures from our assembly and testing that we did this year, a few months ago. So at the top here, you can see some CubeSat members in our clean room for assembly. So we actually have our own clean room that we built at the university. It was very difficult to get the right specs because obviously it's very strict in terms of FODs and like how many particles you can accept in a clean room.
What was the first acronym you used?
The first FODs.
What is
like particles that are in the air that would be basically contaminating the CubeSat.
Oh, like foreign object debris or something like that?
Yes.
Oh, okay.
Yeah. Thank you. Yeah.
That's a Navy word. FOD.
Oh,
That's what they pick up scraps off runways on aircraft carriers and airports because they don't want plane engines to kick them up, and FOD. Yeah, FOD.
Right.
Cool.
Yeah. So that's kind of the acronym that we've been using, but yeah, our clean room meets the specs. It took a few months to assemble it, but yeah, so we were able to assemble the CubeSat. At the bottom left, you can see one of our members assembling the outer panels. And then on the right-hand side, you can see the breadboard test model. So I don't know if you've ever done a breadboard test model, but this is usually really important for prototyping and like experimenting with your electronics. So this was like one of the first test models that we did. And then on the left bottom, so we're not assembling our flight model yet because we're still launching next year at the end of next year. So we still have time. But what you see assembling is it's called the Stm model, so the structural thermal model. And this model, we will be using it to test on a shaker table. So we'll shake it, we'll do vibration testing, we will do TVAC testing, so like in the huge thermal vacuum chambers. And yeah, some parts are 3D printed, such as the cameras you can see here in red, that's a 3D printed part. Because we haven't received our camera yet, and also it was super expensive, so we don't want to test on it too much. We want to include it in the flight model, and
yes.
that's it.
Yes.
Yes, money is always the determining factor in every single choice we make. So
But you printed a camera, a 3D printed camera, so you can do a fit check, right? The form fit
Yeah.
model.
yeah, exactly. Yeah. And also, yeah, some other electronics we haven't received yet, or again, they're just super expensive. So we put kind of like just like a placeholder to still have the weight, like a representative weight of that component, or just a fit check. Yeah. And then here is a better view of the separate CubeSat units ready for integration. And then this is the assembled ECU. So you can see all the boards here, the metal parts, and then we have the little switches here. So these switches are really important. Basically, when we will be having our flight model and we will integrate it in the P-pod. So the P-pod, I'm not sure what the acronym stands for, but it's basically where our CubeSat goes in the rocket. So it has like a little pod where it goes and it gets pushed.
Poly picosat orbital deployer.
Oh,
P-pod.
perfect. Thank
Yeah.
you so much. Yeah, the
Hey,
P-pod.
that one's easy. That one was easy. Quick question: is your chassis one part or 3 sections that you're going to bolt together?
Yeah, that's a good question. So we wanted to, for ease of assembling and disassembling, we wanted to have like 3 separate cubes. And then these cubes are going to be bolted together to the outer panels. So we have like 2 outer panels and then with holes over here, as you can see. And then each cube kind of gets fastened to the side panels.
Is the object in the bottom right corner a side panel? The bottom right corner of that image,
This one
it's the right and below your cursor.
here?
I know the same
Oh, sorry,
picture.
here.
Yeah, is that a side panel?
Yes, exactly. Yeah.
Okay.
Oops, sorry. Yeah, exactly. And then we also anodize them. So black anodize them on the outside, which is why they're like 2 different colors.
Doesn't that make it heat up a lot more, or does it make it dissipate heat faster, or both?
Yeah, because it's black. So the emissivity is really high. So we, well, it's like both dissipating and absorbing a lot of heat. So we will be applying coatings for sure. Because
yeah, let me ask my kids, because I don't think we've used the word emissivity much. Let me ask Castro or Aria or Dylan, Mike, anybody want to take a shot at what emissivity might mean in context? Anyone? Santiago, you have your hand up. What do you think emissivity has to do?
Well, I think in the context that we're talking about here, we're talking about heat and emission, and emissivity sounds like emission. So I'm gonna go with the amount of heat that's taken away from the CubeSat.
Do you approve of that answer, Ms. Stroica?
So I think you're close because you're right. If you have something that's like like you're kind of rejecting heat, but emissivity is more of a material property. So let's say you have, well, not just a material property, but like a surface property. So let's say you're like wearing a white shirt versus a black shirt in the summer, then you will heat up much faster with your black shirt because the color black has a higher emissivity than white. So it's just like a property of a surface. It can be dictated by the color or maybe the roughness of the surface or the finish. Like if it's matte finish or glossy, it affects the emissivity.
Thank you.
Yeah, and then same thing with absorptivity. So yeah, because black, so this finish black has high emissivity and high absorptivity. So it absorbs a lot and it also emits a lot of heat, which is really problematic, like if we face the sun. So yeah, we have no choice but to apply coatings. But on top of this chassis that you see here, we have a lot of little solar panels, kind of like I showed here. Yeah.
Do you have a different coating on the camera side of your satellite that will face the Earth almost all the time versus the side of your CubeSat that faces out into space and the sun part of the time?
Yeah, that's such a good question. So yeah, we are still working on determining exactly which coatings go on which face, but definitely for the side facing the Earth, it's going to be different. We're thinking of using silver Teflon, which is like yeah, it has like a low emissivity and low absorptivity because we don't want that face to change a lot in temperature. We kind of want it to stay stable. And then for the face facing the sun, let's say that we see that our CubeSat gets really, really hot during the analysis, we can choose a coating or a color that we make sure that it doesn't absorb a lot of heat from the sun. So yeah.
The last thing I'm going to say, and I'm going to be quiet, is guys, I think this is a state-winning science fair project for next year, is looking at reflective coatings for their heat properties for satellites. I think for the middle school, you'll win and go to state. I think for high school, that this would be an outstanding project, is to simply look at these coatings as they're applicable to spacecraft. And now I'm done.
Oh yeah, and it's so much fun playing with the coatings. Well, they can be difficult to get a hold of them because some of them are like kind of exclusive. But if you do get a hold of them, it's really a lot of fun to play with them. And then you can like do some experiments in the oven and then like put some sensors to see like to what temperature you get to. But anyways, I will continue. Yeah, so this picture, an overview of the little cubes, the little units, and then the assembled ECU. And then here you can see connectors that go between each board. I'm not very into electronics, so I couldn't answer a very detailed question. But basically these boards were done in-house and then soldered in-house.
Those are 104 connections, right?
Yes.
The PC 104.
PC104.
Santiago, do you have a question you'd like to ask?
Sorry, I just have my hand up.
Well, that's never happened before ever in a Zoom meeting, so that's okay. Go ahead.
And then, yeah, as I was talking about the switches, we need them for the P-pod to make sure that our CubeSat doesn't become operational, like as we put it in the P-pod. We want it to activate the electronic system when it gets out of the P-pod, like when it gets ejected. And then we also have the RBF switch over here.
Hey, Mike McCarty, or one of you older guys, what is the name for those switches, and what does RBF stand for anybody that can answer it? What does RBF stand for? Some of you have them on your keychains. So come on, guys.
Move before flight.
Yeah, there you go, Benji. It's that famous picture. You always take a picture of your satellite in one hand and the RBF switch in the other hand where you've taken it out, right? How about what do we call the switches that she referred to that won't let you power up? Charlie.
Are those MOSFETs?
I was thinking of a word that has two E's. I'm sorry, an E word and an I word. Yes, Colin, thank you.
Fault inhibits.
Yeah, they're electrical inhibit. Yes, very good. Yeah, NASA makes us have like at least 3 different ways that your CubeSat will not power up. We use things like a sun sensor, right? If you're not getting sunlight, you're not going to, well, you're definitely not going to transmit. But yeah, electrical inhibits. Very good, Colin. Please continue, Ms. Stroica.
Awesome. And yeah, I think one of you mentioned MOSFETs, but I just wanted to say that we also have MOSFETs on our CubeSat. So we'll have one somewhere in the interior and one on the exterior. Yeah, just a little fun fact I wanted to mention.
Very cool.
And then a little bit about thermal, which is my field of expertise and my passion. So again, why do we do a thermal analysis? It's to ensure that the CubeSat survives the harsh environment of space. So if we take a look at just the low Earth orbit, it can get really hot and then really cold. So we have about 140 Fahrenheit kind of maximum, and then minimum minus 238 Fahrenheit. So this doesn't mean that your CubeSat will go through these temperatures. It just means that it's going to be living in an environment where it can reach those temperatures. Also, I want to say that I am so uncomfortable with Fahrenheit because we use Celsius in Canadian. So I had to do the conversion before this presentation. But anyways, so yeah, and again,
Yeah, please use, you're free to use, we use metric system, right? Paper
Oh,
mills in the
perfect.
US and citizens don't like it, but science engineering, it has to be the metric system. So yeah,
Awesome.
no,
Yeah, so
no
I
problem.
believe this is 60, like plus 60 degrees Celsius and then minus 150 degrees Celsius. But yeah, basically the electronics are really sensitive. For us in particular, our camera is really sensitive. It has an operational range of like, I think 0 to 30 degrees Celsius. So it's quite tight. And then the batteries are even worse. And so, yeah, again, just an overview of the Earth environment with the sun and then in Leo. So we have a CubeSat here. So the CubeSat receives radiation from the Earth, which can heat it up. It also receives albedo from the Earth. And then the biggest source of heating in orbit is from the sun. So we have the solar radiation, but then in turn, your CubeSat is also radiating to space. And then of course, all of these 3 different heat loads, they vary as you go, let's say in front of the sun or as you go behind the Earth in eclipse. And then depending on if you're passing over polar regions or over desert, your albedo factor will change. Basically, it's quite messy. It really varies a lot. So it's really important that you do a thermal analysis. I know some people do it like in Excel, so just like a simple heat transfer calculation, but we use a software called Siemens NX. So I know a lot of space companies use it as well. It's really fun to use. So we do like a finite element analysis. I just included an example here of the interior of our CubeSat. So you can see that the batteries obviously get the hottest in this case, but we run a lot of cases, like maybe 40, 50 different cases of, depending on where you are on Earth, again, like I mentioned, eclipse or in front of the sun. So we just want to make sure that we capture all different types of cases that we can get. And then we can see, okay, what is the hottest case? What is the coldest case? Is our camera going to make it or not? And then if it doesn't make it, then we design a control system for it. And then, yeah, the topic of my paper in Dubai was how to adapt this thermal analysis for CubeSats as opposed to larger satellites. So like if you take a look online, there's quite a lot of material for thermal, but for large satellites, which sometimes can be a bit difficult to adapt for a small CubeSat, because if you were to do the analysis that they do for large satellites, like in companies, it would take you forever. It would take you a really long time. A CubeSat can accept a bit more risk. So I developed some guidelines to do this thermal analysis, but for a small satellite. And then, yeah, so thermal design, I think is arguably the funnest part of thermal, is when you have a problem in your CubeSat. So from the analysis, it shows that it either gets too hot or too cold. So then this is where you can play with coatings, right? So you have special tapes of different colors and textures. I have an example here. So if you have this panel, this external panel, you could use one coating, or you could even do a mix of coatings. So you could use aluminized foil, polyamide tape, black metal finish, and then kind of put them in a checkered pattern, for example. And then you decide, because basically this is going to give you a combination of emissivity and absorptivity, like we talked about before. That's going to ensure that you get to the temperature that you want your electronics to get to. And then you could also add heaters. So here's an example. If you have your batteries, you can wrap them up in heaters, because for us, our batteries get really, really cold. So it's very easy to just add like a capped on tape heater. I see a question in the chat, I believe. Do you have lamps that you use to test components? Oh, like what kind of lamps?
So when they test the solar panels and they have these really, really bright lamps that simulate the intensity of the sunlight.
Right.
Do you have any lamps like that you do this kind of test, or do you just put it in an oven and heat up the air? Is it like air temperature or do you always test these thermal properties like in a near vacuum?
Right. So I know exactly what types of lamps you're talking about. We don't have access to those. But what we do for thermal testing is, so initially, because access to a TVAC is sometimes difficult and expensive, so we have just a thermal chamber, like without the vacuum. So we have this small thermal chamber at our school, so it doesn't have like the pump to get the vacuum, but it can still give you like a pretty good idea of your coatings and how it works. And then you just put like little thermistors, so like temperature sensors on it. And it still gives you an idea, and then you can compare it with your analysis. But we are currently planning a lot, our testing plan for a TVAC. So we will be testing somewhere in Ontario at an actual TVAC, like a huge TVAC, just to make sure that we're okay. But
If you send it to my kids, they could get it tested for you.
oh, really? You have a TVAC?
No, I'm just saying, if you send your hardware, we'd like to play with it. So,
Oh, yeah. Yeah, definitely. Just hoping that the shipping delays that we get it back in time. But yes, definitely. And then yeah, playing with tapes is so much fun. So yes. All right. And then yeah, I just wanted to say thank you to all our supporters. We have a lot of sponsors, a lot of different supporters. We do have the grant from the CSA, but it's very helpful to have sponsors, that help you and that send you some money to get those extra components. So yeah, I just wanted to say thank you to our supporters, and yeah, I welcome any other questions that you might have.
tremendous, tremendous. All right. I'm just going to stop the screen so I can see everyone's face. All right. Wonderful presentation. All right.
Thank you.
I got 1,000 questions, but I would much rather have you guys ask questions. So, all right, engineers, designers, questions. Mike.
Is the space industry in Canada more private or public? Or I mean, more government or private?
Okay, so I do want to say that first of all, the space industry in Canada is nowhere near as big as the one in the US. So that's first of all. And then second of all, I think it's getting more and more private. We have a lot of small startups that are starting. We have a lot of also kind of big companies that are getting into space. So we have Airbus in Montreal that is hoping to get into Airbus space, like in Canada. That being said, I did work for the Canadian Space Agency, and they kind of govern all the big projects. So like Gateway to the Moon or any other like satellite constellation, they deal with the project management side of things, but then they always relay the engineering side to private companies. So yeah.
Good. Do you guys have any launch sites in Canada? We have one launch site in Alaska and Wallops in Virginia, and of course, Florida and California. And then of course, Musk is going to probably launch from Texas. But do you have any places like that, either for military or civilians, to do suborbital or orbital launches in Canada?
Okay, that's a very good question. So the short answer is no, we don't. We've actually never had like a launcher from Canada. So we've never had like a Canadian rocket launch from Canada. But as part of Space Concordia, the student association that I'm part in, I did mention that we have a rocketry team. So what they're doing right now is they're aiming to build the first Canadian rocket, and they want to launch it this upcoming summer. So they found, they had to get a lot of approvals from the government, but they found this potential launch site in northern Manitoba. So it's like really far away from any civilization. If anything happens to the rocket, hopefully no one gets hurt. But that, I think if that works out, that would be potentially like a launch site in northern Manitoba.
Is it suborbital, and will you allow us to put 100-gram payload on your rocket so we can, fly something else?
Oh, yeah, I don't know. I don't think they have any payload right now, so I could definitely ask. So what they're hoping to do is to reach or like pass the Kármán line.
Mm-hmm.
So yeah.
Yeah, 100 kilometers. Yeah.
Yeah, because they were initially part of the what is it called? I think it's called Base 11 Challenge. I don't know if you've heard of it. but it was like this rocketry challenge worldwide where they promised the first student built rocket $1 million. So if any student team anywhere in the world is able to build a rocket and get it to space, they get $1 million. So that's what we were running for, but the challenge got canceled. So yeah.
I think we heard about that in LA at ISDC in 2018. There was a UCLA or one of those schools in California. We're going to
Mhm.
do it out in the Mojave Desert. They had
Oh,
a
wow.
rocket that was about 15 feet tall, single stage up and down, suborbital. Alex, I think AC, is that you, Alex? Did you want to ask your question? But I think you know the answer now.
Yeah, I was gonna ask if the rocket is orbital or suborbital.
Yeah, I think I answered that.
Yeah, it's up and down, Alex. Yeah, that's cool. All right, any other questions? Come on, throw out your questions. How about how is she going to hear whatever her telemetry is? What's your plan for ground stations?
Okay, so for ground stations, we are currently planning to build it on the roof of our university. So our university is actually really helpful in helping us build it and fund it. But we want to have one more plan B ground station in case that one doesn't work. So we're planning to partner up with the university in Ottawa and build it in Ottawa. So
we got one kid, Colin, who could probably ask some questions about the wavelengths, and he's got an amateur radio license. So
wow.
Are you able to, can you receive your telemetry with like a Yagi antenna, or does it have to be something much larger, like a dish? What type of antenna will you be using to listen to your satellite?
Ooh, that's a very good question. So we're using the Aerospace antenna. Yeah, I would need to speak with my telemetry team. It's an UHF antenna.
Okay.
If that answers.
It means more to Colin than most of us because he's the radio guy.
But that's awesome. I've been planning to get my amateur radio license for a while now. I just need to do the actual exam, but that's cool.
Cool. Any other questions? Questions?
How about? I have a question.
Go ahead.
So for your first CubeSat, why do you choose climate change as a problem to tackle?
Yeah, so the thing with Canada is that most of our satellites have been Earth observation. So Canada is really, really big on that. I think the Canadian Space Agency launched RadarSat mission, which is like a constellation of 3 satellites that are all about Earth observation and climate change. So I think it's just like a theme in Canada, and also there's a lot of professors at universities here that do a lot of research on that. So we wanted to do a mission that will be helpful, and that we would find professors that would take the data and use it for their research. So that's why we chose climate change. Yeah.
Cool.
Okay. And a follow-up question. Why do you choose those 2 points on Earth?
Oh, that's a very good question. So we didn't choose those 2 points. The professors at university chose them. So I think the reason they chose them is because Lake Colhuahuapi in Argentina is currently a lake that's in danger of getting dried up. I think it's been probably dry for maybe a few months now or a year, I'm not too sure. But there are 2 regions on Earth that experience a lot of dust plumes and dust aerosols, which is exactly what we're measuring. So yeah, they were chosen in that angle. Yeah.
Okay, last follow-up question for Michael has a question. How's the dust related to climate change?
So because of climate change, there's a lot more regions that are getting desertified. I believe that's the word. But basically, I know that the Sahara Desert in Africa is growing a lot by the years because of climate change. So I think that's why it's related. Also, Argentina, the lake in Argentina is right on the coast with the Atlantic. And there's a lot of dust plumes from Africa that go to Argentina and that kind of cross the ocean. So both areas are definitely related, but yeah.
So that dust from Africa coming eastward actually impacts our weather in Florida with respect to the the dust become little nuclei for water droplets, I guess, to attach to or something, but it has to do with the rate and severity and frequency of hurricanes for us. And I can't remember, I forget the meteorology, but that dust coming off of Africa really, it actually affects us in Florida. Okay, Mike.
Thank you for your question.
About monitoring the two different locations, what effect or impact would your research have on the climate change?
Right, that's a good question. So I'm not too sure what the professors are hoping to achieve with the data. So I guess I think what they would do with it is to make a case for climate change and hopefully get more laws or more regulations in Canada for climate change, or hopefully in those regions as well. I'm not sure how they could do that, but they are like PhD professors, so it might just be for their research. Yeah.
Charlie.
Okay, so about climate change, how is making laws for your country about climate change when you're studying other countries about their climate change going to help climate change?
Yeah, that's a really good question. I don't know. I think so. For example, the RadarSat mission, the RadarSat constellation, like its main mission is to get climate change data in Canada, but they also get data. Let's say if there's like natural disasters, or when there were like the bushfires in Australia, I remember RadarSat would go and get data and then provide it to Australia. So I'm thinking that maybe they're hoping to sell this data to Argentina and Namibia if professors there are interested in it. And so hopefully sell the data so that they do their own research locally and tackle climate change like that. Yeah. It's just the case with a lot of Earth observation missions where they can get data from other countries and kind of sell the data or give the data. Yeah.
Okay, one more question. So why would Argentina want to handle climate change? Would it directly impact their, let's say, their crops, their growing of crops would directly impact that? And why would they directly want to put towards money and effort to solve climate change in their area?
Yeah, I don't know if they actually will. I don't know if they're actually interested to buy the data, but I know it's a pretty big lake in Argentina. And so I'm not sure about the social economical impact of the drying of that lake, but I believe it definitely affects the communities around it. Now, I'm not sure if the government of Argentina or any sort of other entity would be interested to help, but yeah.
Thank you.
Very good question.
What is the total cost in, actually, if you give it to us in Canadian dollars, we'll try to convert it, but what is the total cost out the door for your 3U CubeSat?
Yeah, so the grant that we got from the CSA is 200K Canadians. We've been trying to stay on budget. Currently, we are over budget by 30K. So currently the cost is $230,000 Canadian.
Does that include your ride and integration or just the hardware?
Yeah, it includes everything. Also includes the building of the ground station, the operation of the ground station, just everything. Yeah.
Cool. All right, questions. Questions.
Mr. Simmons, I just put it into the calculator.
Sandy, I know you said you converted, but I couldn't hear the number. Sebi, you have a question, right?
A bit of a less serious question. I'm just wondering if it's possible to keep in contact. I have family in Montreal, and when I visit there next time, if it's possible, I'd like to maybe tour the university.
Yes, of course. We can bring you to our space lab. Yeah, you could see the actual CubeSat getting built. Yeah, definitely. I would love that. Yes.
So what I heard is you're going to let Sebi have a photo made holding your CubeSat. Is that what I heard, right?
Yes.
Okay.
I didn't say that, but we can definitely do that 100%.
That'd be great. I'm sorry, somebody else was going to speak. Go ahead.
I was gonna say that the current cost of 230,000 Canadian dollars is equal to 180,938 United States dollars.
You know, that sounds like a really good deal for a 3U with a camera. You know, that sounds pretty reasonable.
Yeah, I don't think it's representative of an actual cost of a 3U CubeSat. And definitely CSA is covering a lot of other costs for us. But
Are all your students in classes in English? Because I know you're in that French speaking province or territory. Is it all English where you are?
yeah, so right, Quebec is the French province, but Concordia University is strictly Anglophone. So we all speak English and everything that we do is in English. Yeah.
Cool. All right, 2 more questions. Somebody, how about one of the young ladies with a question about what's it like being something about leading the women in aerospace, women in space. I forgot what you call it. Wise? You're wise.
Yeah.
Any wise questions out there?
What is it like and what made you want to like get involved in like WISE?
Yeah, so basically, definitely it's a male-dominated field. And I think for me, the goal was, so when I was younger, I felt like I didn't really have any female role model, at least in space. I mean, obviously there were all these female astronauts, but they kind of felt out of reach. Obviously, I didn't know them personally. I think I would have really liked to have someone kind of close to me or just someone come to my school and talk about their work in space as a woman. And I didn't have that. I mean, I still made it. I was still inspired to work in this field. But I think my goal was to kind of get this group of women at my university. And then we're planning to do a lot of visits in high schools and elementary schools and kind of just like talk with like little girls and inspire them directly. Just like an impact like that for me was the main driving force. Yeah. I don't know how you feel about that, how you feel about like the importance of having like a female role model. I don't know if you think that's important or not.
Yeah, I totally agree because then you have someone you can model like what you do after.
Yeah.
So some of these girls on the screen, Ms. Stroica, actually wrote a children's book about the ISS and the Falcon 9 first stage. And Finley is one of the authors of that book, and it's on Amazon. It's available. It's all proceeds go to the Wolfpack CubeSat development team. But yes, they do very good work with outreach to younger students. A lot of these kids.
What is it called?
I have it right here.
There you go. Plug that book. Let's go to space.
So cool. Awesome.
Yeah, we say that a lot. Let's go to space. All right, one last question. Any rock star out there? Harriet, do you have a question?
How did you discover SWICE?
Yeah, so I was on Instagram kind of going through different pages and I found this page of, it was called SWICE Official. So that's the official Society of Women in Space Exploration. And so I kind of like stalked their website, kind of see what they're about. And then at the end of the website, it was like, start your own chapter now. And it was like this application form. And I was like, yeah, let's do it. Let's start my own chapter in Canada, you know? And so I just like did the application and now we have SWICE at Concordia. But it's really cool because sometimes we're chatting with SWICE from other provinces or other countries. So like we've been in contact with the SWICE in Florida from Embry-Riddle, which is also where I did my exchange last semester, which by the way, I absolutely loved Florida. Yeah. But yeah, we've been in contact with SWICE from Embry-Riddle and just kind of all over the world. So it's really cool.
Is there a minimum age that girls could join SWICE?
No, not really. I mean, not for our SWICE. We're kind of open to anybody joining. Yeah.
Cool. All right. Anybody got a final question for our VIP speaker? Sebi.
All right, so last question. Again, not too serious. Your name sounds a bit Romanian. Do you speak Romanian?
Yes, I'm Romanian.
Huh.
Yeah, right. You hit it right on because you could have said Russian or something, but yes. Yeah, I was born in Romania and I speak full Romanian. So yeah.
My parents are from Romania.
Oh, cool. Do you speak Romanian?
No, numai un pic.
Okay. Oh, that's so cool. Yes, definitely come to Montreal. I will show you around their space lab. You will love it.
Excellent. We hope you and your team will come to SmallSat in Logan, Utah at Utah State, because we actually go there every year when it's live and we exhibit, we compete in the poster competition. If you could submit a paper, then we can come clap for you while you present it in Utah, but that's the world's biggest gathering for CubeSats.
I would love that. I've been trying to get to SmallSat for a really long time. Do you know when it's happening this year?
I
mean,
do.
2020.
It's always the first week in August, probably like the 4th through the 8th, kind of something like that.
Okay.
Yeah, but you know what? I'll let one of my kids email you. If it's okay to share your email with the team, would that be okay?
Absolutely. Yeah, definitely.
I probably shouldn't have put you on the spot like that, but I'll let, I can let one of the kids keep you in the loop on things we're doing that might be of interest to you guys, but we would love to coordinate with you. And Sebi, obviously, if he gets up there, we would love him to be our ambassador with you guys and reach out. So, all right, how about a big virtual round of applause for our very important person guest tonight? Yes.
Thank you guys.
Such silence out there. Yes. Oh,
I had so much fun, and your questions were sometimes really challenging, and I loved it. It was amazing.
excellent, excellent. Well, we have this little thing we do, Miss Stroica. Everyone turn your cameras on. I think you know what we have to do. It's what we do at the end.
Oh.
We throw up our Vulcan gang symbol, and
Okay.
I take a screenshot. So I have it. Everybody got it up? All right. Thank you guys so much. Awesome.